This conference will now be recorded.
In today's session, we'll try to understand Terraform core workflow. So before we try to create any resources, before we create any resources using Terraform, first we have to understand the Terraform core workflow. So this consists of three things basically. One is plan, basically next one is write, next one is write, next one is apply. So basically this plan is nothing but you have to identify the scope of the resources. Here we have three important stages in this Terraform workflow: plan, write, apply. This apply can be whether you wanted to create, whether you wanted to update, whether you wanted to delete, whatever you wanted to do. So here Terraform core workflow, as I already said, the most important thing here is to understand your infrastructure needs, like what resources needs to be managed via Terraform. After identifying the scope, after planning what resources you wanted to create and manage via Terraform, the next one you are going to write you are going to write your Terraform configuration scripts, just like you write the code in your favorite editor of your choice, right? You are going to write. So here there is something called Terraform workflow or Terraform core workflow. Terraform workflow, or we call it as a Terraform core, the core Terraform workflow. So it has a three important steps. That core Terraform workflow has a three steps, right? Write, plan, apply, like that. So before you write itself, you have to identify the scope. Before you write the Terraform code, you have to identify the scope. You have to identify the scope of the resources, the scope of the infrastructure. What resources you have to identify? You have to identify what resources has to be created. After that, you can write your code. You are going to develop your infrastructure as a code, and you can preview the changes. Plan means you can preview the changes. So Terraform plan will show what resources needs to be created, what resources needs to be updated, what resources needs to be deleted. It will preview, it will show what resources to be created, what resources to be modified, what resources to be created, what resources to be modified, what resources to be destroyed. It will be preview the changes, it will show. Then if you are okay with that plan that can be creating or updating, deleting resources, then you can apply. Then you can apply that changes, you can apply that code, that preview. So here, before we write, you have to identify the scope of the infrastructure. So here, first, you have to identify the scope of the infrastructure, what resources you have to create via Terraform. Then you can write your Terraform configurations. You write Terraform configuration just like you write the code in your editor of your choice, right? You can write your code. You can maintain that code in the version control systems also, like that. And again, plan, plan. You can execute a Terraform plan. If you execute, it will preview the changes. It will display the changes. What resources has to be created, what resources has to be updated, what resources to be deleted. It will preview. If you are okay with that plan, then you can apply. You can apply after you can apply so that Terraform will create or update or delete the real infrastructure like that. So here you are going to identify the scope of the resources to be created. After that, you are going to write. After that, you are going to write the code as per the scope. Then you can preview. Before you actually create or update, Terraform can show the preview like what resources to be created, what resources to be updated, what resources to be deleted. It will show the preview, like a trailer, what is going to be created, what is going to be deleted, it will show. Then if you are okay with that changes, or if you okay with that plan, then you can proceed further and you can apply, so that Terraform can create update resources according to the plan, according to the plan. But here there are so many other things here in the workflow. So here we will try to understand what is this Terraform init will do, what is this Terraform validate will do, what is this Terraform plan will do, apply, destroy, like that. We'll try to understand. So once you identify the scope of the resources, once you identify the scope of the resources that has to be created via Terraform, you will write the code. You will write the code. Let's say you wanted to create a resources, your scope. Let's say your scope is I want to create, scope is create two EC2 instances. Let's say I want to create a two EC2 instances in AWS. Okay, in Mumbai region. In Mumbai region. Then this is the scope. Create a two EC2 instances in AWS Mumbai region using let's say Red Hat AMI. Just to give an example, I need a server with Red Hat AMI. And not only that AMI, what type of instance? Maybe the requirement says I need both servers with the T2.micro, like that. Or maybe one server. Maybe if you have a requirement, one server with Red Hat AMI. Maybe you have a requirement, one server with Red Hat AMI and T2.micro. And one more server, maybe if you have a requirement Red Hat AMI only, but a T2.large. I need T2.medium. So this is like a scope. This is like a scope of the what scope is nothing but requirement. You have to identify the scope. So what resources you have to create using Terraform, you have to identify. Let's say this is my requirement, create a two EC2 instances using Red Hat AMI, one with the T2.micro, another with the T2.large, like that. Or maybe same, maybe in one is in 1A availability zone, another is in 1B availability zone, like that. This is your scope. Once you identify the scope, you are going to start writing the code with whatever editor of your choice. Whatever editor of your choice, that can be Notepad++, that can be Visual Studio Code. But I will explain how to install Visual Studio Code also later. Now I have to identify the scope, and after that I am going to write. I am going to write the code. So maybe since I have to create a EC2 instances. EC2 is a resource from which provider? AWS provider. So in my Terraform code, I will write a Terraform code. I'll write a Terraform code with the .tf file extension. The .tf file extension, I'll write the code. Suppose you will start first open Notepad or any other thing. So you will say save as maybe that can be anywhere in your local laptop. Maybe you will create one folder. Maybe you will create one folder like this. You will create one folder if you already have a folder. Maybe within that folder, you will create one file like main.tf. But instead of normal text file, you will go and select maybe if you are using Notepad plus plus, you can select maybe all files, like that. If there is no support for Terraform, so you can say all files type. There is something called all files, all types. But here you can give extension that can be anything, main.tf or anything like this you can create. Then you will, this is like this folder this folder that contains even single .tf file also become a module. This folder that contains a single .tf file also becomes a module. When we are executing a Terraform commands, from this directory, this is like a root module. like that. So once you create a file like this, you will start write the code. You'll write the code. So since the EC2 is a AWS resource, first you have to use a Terraform block. You have to use a Terraform block. You have to mention the provider. So providers also will come from where? Providers will come from where? Terraform registry. So you can go to the registry. You can go to the registry, Terraform registry, and you can search the providers. Terraform registry. You can go to the Terraform registry. You can find the providers. You can find the providers. So since I have to create a AWS resources, I can go and find browse providers, AWS provider. So here, if you are using older versions of the Terraform, different way, latest version Terraform 0.13 and above, you are going to provide these details like this provider block. In this provider block, required providers, AWS provider. This is like a version of the provider. If required, you can use some other fields also, like required version. Required version. This is like a Terraform software version. So which version you can say if required, this can be greater than or equals to 1.3.0, like that you can say Terraform software CLI version. But if you don't mention, it will not check in which version you are running the script. It will not check. If required, you can mention this version, required version also, like this you can mention. But provider related settings, you are saying required provider is AWS, but provider related settings, like maybe some providers has to have some other details, like in case of AWS provider, like region, access keys, secret keys, those type of things. So here, that provider related settings can be defined using which block? Again, suppose in which region it has to be created, there is something called provider block. There is something called provider block. So in this provider block, you can give provider related settings. This provider block, you can give provider related settings. Again, what arguments can be defined in the provider block also, they will define in the official documentation only. They are going to show in the official documentation only. They are going to show in the official documentation only, provider related options also. Let me go AWS provider. Let me go to the documentation. They are going to tell how we can use this provider also. If you scroll down, they are going to tell the documentation. Go to this, and if you scroll down, how you can use the Terraform block like this provider. Like if you scroll little down, you have to authenticate, right? Configuration for the AWS provider. Configuration for the AWS provider, you have to authenticate. You can provide the parameters in the provider configuration or environment variables, like that. If you scroll down, they are going to tell how to authenticate also, and what options we can use in the provider block. In the provider block, what options we can use for Terraform. You can use roles, or you can use access keys, secret keys also, or you can use profile, AWS CLI profile. So all these are like options. Under the provider for AWS, you can use access ID, secret key, access key, secret key, or a region. These are like options in the provider block. Suppose here I can say in which region I have to create that resources. Suppose my requirement is a Mumbai region. Can I say region equals to AP hyphen south hyphen 1, like that? So Terraform knows that in AWS provider, the resources has to be created in this region, like that it will know. Similarly, AWS provider, AWS will not allow to create a resources without authentication and authorization. So here, programmatic access, you can use access keys, secret keys, like that also. Those options also you can specify. Your access key, whatever access key of your AWS user, like this, and a secret key. But again, it is not recommended to provide a confidential data kind of access keys and secret keys in the code, because in real time Are we going to check in? Are we going to maintain this code into the version control system? Yes. So hard coding also okay, but the main problem here is security, right? This is like a confidential data, security breach, security risk. You are maintaining these access keys and secret keys in the source code, and you are committing into the version control system. And whoever has access to the version control system, will they able to see these access keys and secret keys? Is there a possibility that they can misuse these access keys and secret keys in other programs or other applications like that? Yes. So we should not maintain this in the version control system. So there is a different ways to provide these details that we will see later. That we will see later. But for now, understand, using Terraform block, you are telling the Terraform which provider or which plugins Terraform can install and create a resources, and provider related settings you can provide here like this. Then the most important block in the Terraform, the backbone for the Terraform any configuration is which block? That no need to be always a secret manager. There are n number of ways. You can set it as an environment variables. There are so many ways. No need to be secret manager. You can set it as an environment variables before running the Terraform scripts in that server. In that server, in whatever server you are executing the script, you can set as an environment variables this access key and secret key. Outside of the Terraform you can set. And again, you can create a, you can attach a role. You can attach a role. Suppose you are running this scripts in the AWS EC2, you create one IAM role and you can attach that IAM role to the EC2 instance. So in the EC2 instance you are running the script, so that the Terraform will use that role, IAM role. Suppose you are running in your any other system also, you can set as an environment variable before running the script. There are plenty of ways. There is no single approach. Now we created a Terraform block, we define the provider block, the backbone of any Terraform configurations. What is the resource block? So now my scope is this. I want to create a EC2 instance. So is that AWS provider is going to add the set of resource types that can be created and managed via that provider? Yes. So where we can see what resource types will be added to the Terraform by that provider, and what data sources will be added to the Terraform by that provider that can manage via Terraform. Where we can see what resource types is added to the Terraform, and what data sources will be added to the Terraform by that providers, that we can see in the official documentation. So here left hand side you can see like all this section. Now I want to create a EC2, elastic compute cloud, EC2. So let me expand this EC2 section, elastic compute cloud. There is a resources and there is a data sources. There is a resources and there is a data sources. There is a resources and there is a data sources. The way we can create a resources using Terraform providers by that resource types, similarly you can get the data, you can get the data about that resources also. You can get the data about that sources. Suppose you want to get existing EC2 details, suppose you want to get AMIs, you can use data sources. But for now I wanted to create a EC2. Can I go and use this resource type AWS underscore instance to create a AWS instance? Yes. So this provides an EC2 instance resource. So I can create a resource, something like this resource block. In my code, I can write it like this resource block, AWS underscore instance, AWS underscore instance, and whatever label, like a list, resource name or a label. This can be used within the Terraform. So here I'm saying I want to create a AWS instance resource. But here, without providing any arguments to this resource, does Terraform, with the help of that provider, will it able to create a EC2 instance without knowing what AMI has to be used, what instance type has to be used, like that, it will not able to create. So every resource type will have its own arguments. Every resource type will have its own set of arguments. Every resource type will have its own set of arguments. Again, something will be mandatory arguments, something will be not mandatory. Again, where we can see what arguments can be used for that resource type. Again, official documentation only. If you scroll down here, they are going to tell arguments reference for this resource. Arguments reference for this resource. This resource, what is this resource here? This resource is basically EC2 resource. This resource is basically the EC2 resource. So this resource type AWS underscore instance resource type supports these arguments. One is AMI. So AMI. So whenever you are creating a EC2 instance, you can use a AMI. So you can provide AMI equals to something like this. AMI equals to, if you know the AMI ID, you can directly give the AMI ID. Otherwise, go to your AWS console. And get the AMI ID of Red Hat. Otherwise, as I already said, using data sources, you can retrieve the data. Otherwise, you can provide this AMI ID. Suppose you wanted to create a EC2 instance using Red Hat AMI. So most commonly used AMIs, community AMIs. So let's say Red Hat AMI, this AMI ID. Otherwise, you can retrieve this also using data sources that we will see later. Now, instance type. Again, that is also one more argument. For that resource. So we provided AMI. Similarly, if you scroll down, there is something called instance type. That is one more argument for that resource. What type of instance has to be created? And again, this is required. This instance type is required unless a launch template is used. Suppose if you have mentioned the launch template, suppose you can say this EC2 has to be created using launch template, like that. If you are saying that time instance type is defined in the launch template, so no need to give instance type. But we are not using launch template, so we are directly creating EC2. So we are saying this is the instance type t2.micro as per my requirement. And similarly, there are so many arguments. Mandatory arguments are there, non-mandatory arguments also there. Mandatory arguments also there, not mandatory arguments also there. Now, if required, you can give a tags. Tags are like a map of objects. Here you can say name equals to just a web server. Multiple tags also you can give. Managed managed by Terraform, like that you can give. Managed Terraform, like that you can give. Suppose if I don't mention other options like availability zone, subnet ID, security group ID, if I don't mention those things, then they will be created in the default VPC, default availability zones with the default security group. Everything there is a defaults, right? So it will use those. But in real time, based on your requirement, you can specify what security group has to be used with this EC2, under which subnetwork this EC2 has to be created, under which availability zone this has to be created, like that also you can specify. But for now, let's understand the basics, fundamentals. So if I create a resource like this, if I run this script, the Terraform will download this AWS provider, AWS plugin, and using this details, using this provider configurations, AWS resource will be created. But how many servers will be created with this script if I run? Only one. If required, there is something called meta arguments, arguments and meta arguments. I will come to that. Suppose if I have to create two instances, I can mention like this. Don't worry, I will explain this detailed meta arguments also. Suppose if I say count equals to 2, so using this arguments, how many EC2 instances will be created? If I mention like this, 2. But I will explain this count for each again in the future classes, don't worry. But my requirement, one instance with this AMI, this instance type, another instance is with a different AMI. That time I can write a code in a different ways also. For now, let's write maybe this way. I can write in a so many ways. For now, let's say, suppose if I create one more resource block, here I am saying t2.medium. So if I run this script, this block will create one EC2 instance using this AMI, this instance type. This is going to create a one more EC2 instance with this AMI, this like that. But as I already said, the combination of this resource type and this resource name should be unique. Suppose this one combination should be unique. Suppose if I have a combination of resource type and resource name same, Terraform will throw error. So here you can have any other thing. That can be anything like this. Anything is also fine. But this is not your server name. This is like a label for this resource, like a name of the resource. This can be referred in the other section of the Terraform code. Now you identify the scope and you have written a code like this. So first you have identified the scope. First you have identified the scope of the resources. My scope, my requirement is I want to create a two EC2 instances in a Mumbai region using Red Hat AMI, one with the Red Hat AMI T2.micro, another with the Red Hat AMI T2.large, like that. As per this scope, you have written the code. Then after that, there is a workflow. There is a workflow here. So you are going to identify the scope of the resources to be created. Then you develop the code. You have written the Terraform code in your editor of your choice. Now, then this workflow will start. So there is something called Terraform init. So after you identify the scope, after you have written the code, you can go to this folder. You can go to that folder where you have written your script. You can go to this folder where you have written your script. You can go to this folder from this directory. From this directory, you can go to this folder. You can go to this folder. Here you have a code. Even a single file, single Terraform file, a single Terraform file in a directory becomes a module. Now there is a Terraform file in this directory. There is a Terraform file in this directory. So this is considered as a Terraform module. A single Terraform contains a single Terraform file in the directory becomes a module. When we are running the Terraform commands from such a directory, that is root, the contents of that folder becomes the root module, like that. So here, once you have written, you can run the Terraform commands. The first one, you can execute a Terraform init. So what this Terraform init will do, we have to understand what this Terraform init will do. It will try to, this command will initialize the working directory containing a Terraform configuration files. By default, this command will initialize. This command is going to initialize a working directory containing a Terraform configuration files. By default, Terraform init assumes that the directory already have a Terraform configuration files. But without a Terraform configuration file in this directory, if you are executing Terraform init, does Terraform can understand what to do? Suppose without a Terraform configuration files in this directory, if you are executing a Terraform commands, that can be Terraform init, Terraform plan, like that, does Terraform can understand what to do? No. So it will throw out error. So this Terraform init, this is going to initialize the Terraform. What do you mean by the initialization? What it is going to initialize? It is going to initialize, or it is going to download. It is going to download that providers, that plugins, whatever provider you have told the Terraform to use for creating resources. It will download that providers or that plugins. From where it will download? To that working directory, the Terraform working directory, that root directory, root module. From where it will download? That will be downloaded from the Terraform registry. Terraform registry. So this Terraform command, Terraform init command, the Terraform init command is going to initialize a working directory containing the Terraform configuration files. By default, Terraform init will assume that that directory already contains a Terraform configuration files, and it will attempt to initialize that configuration. This is the first command. This is the first command you should run. This is the first command you should run after creating a new Terraform configurations or cloning the existing one from the version control system. So this is the first command you should run after writing a new Terraform configuration files. Otherwise, already Terraform configurations are there, but they are committed in the version control system. Maybe you are cloning. You have not developed. Maybe I have developed. Maybe I have developed the Terraform configuration. I have written the Terraform configuration. I have committed that to the version control system. Maybe Vivek is also from the same team. Vivek no need to write again. He can clone. He can clone the Terraform configurations from the version control system. So whether you are cloning the Terraform configurations from the version control system, whether you are writing a new configurations, this is the first command you have to run. This is the first command we should run after writing a new Terraform configurations or cloning the existing one from the version control system. And again, is it safe to run this command n number of times also? Can I execute Terraform init 10 times, 20 times also? Is it safe? Yes, it is a safe to run any number of times. Basically, what it will do, what this Terraform init will do, this Terraform init will perform several different initialization steps. This Terraform init will perform several different initialization steps in order to prepare the working directory for using with Terraform. So this command, Terraform init command, will perform several different steps in order to prepare the current working directory for using with the Terraform. So first it will do the initialization, backend initialization. What do you mean by backend? As I already said, you can use a local backend or you can use a remote backend. But here in this Terraform block, as of now, I have not mentioned the backend related settings. So if I don't mention the backend related settings, what is the default backend? It will use for creating and maintaining the state file of the resources. In this, I have not mentioned the backend details in which a Terraform can create, maintain, and manage the state file of the resources, the current state of the resources. We can mention using backend, but since I have not mentioned, it is going to use a local backend. But suppose I will explain, don't worry, in the future sessions. Suppose I have mentioned the backend. Suppose in the Terraform block, I can mention the backend also. So backend, suppose I have given S3 as a backend. So is it going to initialize that backend also? Is it going to check whether there is a S3 bucket with that name, whether I have a permissions to create update files in that S3 bucket like that? Is it going to verify the backend? Yes. So first it will check the backend, whether there is a backend with that S3 bucket or not, whether I have a permissions or not, is there any state file already in that backend or not, it will check. So we can mention the backends. I will explain this remote backends later. So Terraform backend, like S3 also you can use. Suppose you are using AWS, you can use S3 as a backend. So like this in the Terraform block, you can mention backend. Like this in the Terraform block, you can mention the backend. If you are using AWS, you can mention backend bucket. This is my bucket name. In that bucket, with this name, the Terraform state file has to be stored. The bucket in whatever region, in what region you have a bucket, you can mention. Understand, this is backend, not a resource. Suppose if I do like this, do you think the bucket will be created using this backend details? Do you think bucket will be created? No. So this is like a existing bucket. This is like an existing bucket in which it is going to maintain the state file. Instead of local backend, it can maintain the state file in the remote backend. But if I have a backend details like this, it will do the backend initialization. Backend initialization means it is going to verify, do you have a bucket with that name in that region, or is there any state file already there in that bucket? Like that, it will check. So that is called as a backend initialization. But if I don't have a backend mentioned in this Terraform block, Terraform will use which backend by default to maintain the state file again? Local, local backend, local backend. Key means not a PEM file, guys. Your key means of name of the file, object name in the S3. Whenever your key means not a PEM file, guys. Whenever you are uploading any object to S3, in that the name, object name, file name. So here, what is the state file name? What is the name of the state file? That has to be created and maintained in the S3 bucket. That is the meaning of key there. So the state file name that has to be maintained in the S3 bucket. That is the key name here. It is not a PEM file. S3 doesn't do with anything related to PEM file, right? That is the name of the state file. So it will do the backend initialization. But do you think this is the only initialization it will do when we are executing Terraform init? No. After that, plugins. It is going to download and install that plugins that providers. Suppose here I have mentioned provider like AWS. So these providers are nothing but a plugins. These plugins get downloaded. These plugins get downloaded from Terraform registry to that directory, to that root module, root directory. It is going to download and install that plugins to the Terraform working directory. Then again, child modules. Suppose you are using any modules. Suppose you are using modules from the remote sources again. Suppose you are using a modules to create a resources from Terraform registry or any other your own repositories, that will download those modules code also to that working directory. So this is like a the first command. This is like a first command which you are going to run after creating any new Terraform configurations or after cloning any existing Terraform configurations also. It is safe to run n number of times. Understand, maybe later in the future, suppose if you have modified this Terraform block again, suppose currently you created a resources with this AWS provider 5.70.0, but maybe in the future you upgraded this version. Again, do you need to again reinitialize? If you are making any changes to this Terraform block, do we need to reinitialize again the Terraform? Yes. If you are making any changes again in the future to this Terraform block, you make any changes in this block, you have to reinitialize the Terraform again. Understand what I'm trying to say? Maybe you are making some changes to this Terraform block. You have to again execute the Terraform init to reinitialize the Terraform to reflect that changes, like that. So understand what is this Terraform init, what exactly it will do. This command is going to perform some kind of a initialization tasks. This command will perform several different initialization steps in order to prepare the current working directory for using with Terraform. So it is going to download the providers, it is going to do the backend initialization, it is going to download any modules if you are using in modules in the current Terraform code, like that. So this is the first command which you have to execute after writing a new Terraform configurations or cloning an existing one from the version control system. And it is safe to run this command multiple times. But if I only execute Terraform init, is it going to create a resources whatever I have mentioned in this code? Is it going to create a resources whatever I have mentioned in this code if I only execute Terraform init? No. So after that, you can go with some other commands. After that, you can go with some other workflow. But without a Terraform init executed, if I directly apply, do you think the Terraform can do that? No. So the first one, the first one, whatever you are writing, right? So the first one you have to execute Terraform init. So if there are any changes in the version control system, Terraform will init will take effect, which you have to execute, right? Version control system is different, Terraform flow is different. Suppose just forget about Terraform. You guys created a CI/CD pipelines for your application. Whenever there is a change to your application code, is that package is automatically built? Is that application is automatically deployed? Forget about Terraform. Suppose you are, let's take application. You developed one application. You developed one application, let's say Java based application, Python based application, or maybe static website, that doesn't matter. You are maintaining that application code into the version control system. Any changes the developers will make into the application code, is that code will be automatically deployed? If you understand, no, right? You have to manually take that code, execute that code, deploy the code like that. Now similarly, if you want to do an automation for application, or you guys can integrate with the CI/CD tools like that. Can you create a CI pipeline for your application code, CD pipeline for your application code, so that whenever there is a change in the application code, if there is a CI pipeline, is that CI pipeline will continuously integrate, take the code, compile the code, create a package, and store that package into the artifactory like that. Then the CD package, the CD package deployment, CD pipeline, the deployment pipeline can execute and it can take that package and deploy in your deployment server like that. Similarly here, you are maintaining the Terraform code in the version control system. You can manually get the code, do the Terraform initialization, Terraform apply manually. Otherwise, you don't want to do it manually. The way you guys created a CI pipeline for your application code, your application repository, can I create a CI pipelines for infrastructure as a code repositories also, like my Terraform code repositories also? So whenever there is a commit to the infrastructure code, whenever there is a changes to the IAC code committed by me or you, like in the version control system, I can have a CI pipeline created. In that CI pipeline, you can implement this workflow. So get the latest Terraform code, execute Terraform in it. After that Terraform plan, after that Terraform apply like that, you can have a stages or a steps that can do the automation. Whenever there is a change to the infrastructure, if you have a pipeline, that pipeline can trigger this workflow instead of manually. So that is the CI concept. So first we are learning Terraform. If you know Terraform and if you also know CI, can we integrate this Terraform with the, I mean to say, can we have a CI pipeline, CD pipe, I mean to say, can we have a CI pipelines created for Terraform code also? Yes. If you know Jenkins, you clone the repository in that stages or steps in the Jenkins pipeline. You have these commands like a Terra one stage, after that a Terraform plan, one more stage, after that a Terraform apply or maybe destroy as per your needs like that. Clear? But manually, I mean to say automatically, it will not initialize, it will not deploy. That you have to do either manually or your pipeline will do instead of manually. Clear? But it is your responsibility to create a pipelines also according to your needs. Clear? Now this is the first command you have to execute. Terraform init is the first command you have to execute after cloning the existing code from a version control system, or maybe you are creating a new one. This is going to perform these activities. After this, next one is Terraform validate. But validate is not mandatory. Validate is not mandatory, but you can validate. The name itself, it is saying validate. So if I execute Terraform validate, what it will do? It is going to validate the Terraform configuration files in the perspective to the directory. It is going to validate the syntactical checks. It is going to validate the Terraform configurations. So this Terraform validator, this Terraform validate will validate the Terraform configuration files in that perspective, in that respective directory. So whatever Terraform configuration files you have in that root module, whatever Terraform configurations we have in the root module, the Terraform validate will validate those configuration files to ensure that they are syntactically valid and internally consistent also. It is not mandatory. If without running validate you can proceed, but if there is a syntactical issues, if you proceed also, it will throw error. Without validate you can apply, but if there is any syntactical issues, is that apply will work, is that plan will work? If there are any syntactical issues again, no, it will throw error. But if required, you can validate. Terraform validate. It is going to validate the Terraform configuration files in that respective directory. Suppose from here, suppose in this Terraform folder, this is the module. I can consider this as a module where I have a Terraform code. In this directory, if I execute Terraform init, the Terraform will download this plugin, this provider to that working directory. Then if I validate, it will validate whether this Terraform code, this Terraform configurations are syntactically correct and internally consistent or not, like that. So it is not mandatory, but you can validate. So this Terraform validate, this validate command, does exactly what its name suggests. It will check the code and syntactical errors. Why we need to validate before running? So like you as a safety check, right? Suppose before you execute, you can check whether the code is, whatever code I have written is syntactically correct or not. You can check why you need to run and check whether that is code is correct or not, the syntax are correct or not. Without running that code also you can verify. So that is what validate does, like a dry run, guys. Ansible playbooks dry run, Kubernetes YML's dry run you are doing, right? Same thing here. Syntactically, you can verify whether they are correct or not. Why you have to run, then see the errors? Syntactical errors. Without running that code, I mean to say, you can validate without executing that code also by using Terraform validate. So this is the one more command. This validate command does exactly what its name is suggesting. It is going to check that code. It is going to check that code for a syntax errors. Ensure that it is internally consistent. It will look only at the Terraform files in the current working directory. Again, this validate, it will only looks at the Terraform configurations in the current working directory. But if you are using a child module, submodules, they are not going to validate the Terraform files in the submodules or a child modules. If you want to validate the files inside the submodules or directory, you have to use a Terraform validate hyphen recursive option. So if you are using, suppose you are using a modules concept, within this you have a child module, within this you have a one more folder, within this folder you have some Terraform configuration files, modules concept, those modules related Terraform configuration files, it will not validate. If you have to validate that modules code also inside that root module, if you have a child modules, you can use a Terraform validate hyphen recursive flag. So recursively also it will validate the configuration files, whatever it is there in the modules or a directories inside. So this is just for validation. The next one is Terraform plan. So what this Terraform plan will do? This Terraform plan will try to create an execution plan. This Terraform plan will try to create an execution plan. This Terraform plan command, the Terraform plan command, it is going to create an execution plan. It is going to preview the resources, what resources to be created, what resources to be updated, what resources to be deleted. It will preview that by running this command. Without a plan, if you directly apply also, it will do the plan. Understand? Suppose without running this Terraform plan, if you directly after Terraform init, if you directly execute Terraform apply also, this apply also, even though you have not done this Terraform plan, even though you have not executed this, but still when you are running this Terraform apply also directly, again it will preview, and it will show for a confirmation. So these resources I am going to create, these resources I am going to update, these resources I am going to delete. Are you fine with that? If I say yes, then it will proceed further. So even though you don't do the plan, Terraform apply also will internally create an execution plan. But without running up, without applying also, if you have to only do the planning preview, you can do this Terraform plan. So this Terraform plan command will try to create an execution plan, which will let you to preview the changes, what resources to be created, what resources to be updated, what resources to be destroyed. It will show you. So by default, when the Terraform creates the plan, how it is going to know what resources to be created, what resources to be updated, what resources to be deleted? It is going to take a state file. It is going to read the state file. So this Terraform plan will read the current state of the any existing objects, whatever you have already created, right? It will maintain that in the state file. So Terraform plan will read the current state of any already existing remote objects to make sure that the Terraform state is up to date. It is going to compare the current configuration. It is going to compare the current configuration, that is your desired state. That is your desired state, your code. It is going to compare the current configuration, that is your desired state, your code, to the prior state. Prior state means whatever resources which is already created and maintained that in the state file. If there is any differences, if there is any differences in the desired state and current state, that resource will be updated. But in the desired state there is a resource, but in the current state there is no resource, which means that the server is not already created. In the desired state there is a resource, but in the state file that resource details are not there. In that case, Terraform will say I have to create this resource. But in the desired state also there is a resource, in the current state also there is a resource, and there is no difference between those two. In that case it will say no changes, I no need to update like this. And if the desired state, if the desired state there is a resource, desired state means in your Terraform code, desired state means in your Terraform code there is a resource, but there is no record, there is no record, or there is no entry for this resource in the state file. The previously created resources that will be maintained in the state file. In the state file there is no entry for this resource. In that case, in the desired state there is a resource, but in the current state, in the existing infrastructure, there is no server. So in that time, what the Terraform will say, I have to create this resource, I have to create this resource, like that it will show. And in the desired state also there is a resource. In current state is also there is a resource. But earlier you created a server with, let's say, t2.micro. In the state file, there is a mapping for this resource, but t2.micro it is there. But now in the code you have said t2.large. In the desired state, the server is t2.large, but the server is already there, the resource is already there. But in the current state the instance type is t2.micro. So in that case, do you have a difference between the desired state and current state? Desired state is your Terraform configurations, current state is the resources that is already created and maintained in the state file. So if there is a difference in the desired state and current state, is the Terraform is going to match this desired state with current state? Is that the machine type will be updated in the real infrastructure like AWS, and again is that will be updated in the state file also? Yes. But this Terraform plan will compare, this Terraform plan will compare the desired state and current state, and it will preview the changes. But is this Terraform plan will make the changes? Preview is different, making is different. This Terraform plan will just preview the changes. What resources to be created, what resources to be modified, what resources to be destroyed, like that. It will preview those changes. But it is not going to make any changes. It will preview. But if you are okay with this changes, can you proceed further and apply that changes by running the Terraform apply? Yes. But if you don't want to make those changes, if you don't want to make those changes, don't run the Terraform apply. So this Terraform plan, what it will do basically, Terraform plan command will create an execution plan. Terraform command will create an execution plan which will let you to preview the changes that has to be created, updated, deleted, that Terraform plans to make your infrastructure. So it will read the current state of the any existing remote resources that is already created and maintained in the state file, and it is going to compare that current state with the desired state, that is your configuration. Differences, it will try to show what resource to be created, what resources to be modified, what resources to be deleted, like that it will show that preview. So understand what this Terraform plan will do actually. What this Terraform plan will do actually. Everyone clear? For the first time, suppose I have created this infrastructure as a code. For the first time, if I am running Terraform plan or Terraform apply, so do you think, is there any resources already created using this, and is there any information about these resources in the state file for the first time if I am running this scripts? For the first time if I am running that script, there is no state file. First of all, there is no resources, there is no state file. That time what it will say, is it going to say I have to create one resource with this AMI, this instance type, this tags, another instance with this AMI, this instance type, like that? Is it going to tell when I say Terraform plan? Yes. So for the first time, if you are running, there is no resources already created and there is no information in the state file. So there is no state file. That time, if I say Terraform plan, Terraform apply, it is going to tell I need to create this instance with these details. I have to create this instance with this details, like that. It will show if you are running Terraform plan. For the first time if you are running, there is no servers created via Terraform, there is no information about the resources in the state file. That time it will say I have to create a resources. So if you apply, the resources will be created. After applying, the resources will be created and that resource details will be maintained in the state file also. And again, without making any changes, again and again, if you are running Terraform apply, like that, do you think, is it going to create resources or is it going to modify resources if there is no changes to the desired state and current state? No. So Terraform plan will just show the execution plan. Terraform plan will just prepare an execution plan and it will preview. It will preview that state file, comparing the state file with the configurations. It will show what resources to be created, what resources to be modified, updated, like that. But it will not make any changes. It will just compare the current state, that is state file, with your configuration, and it will preview the changes to be created, updated, modified, like that. So everyone clear what this Terraform plan will do actually? Now the next one is Terraform apply. Terraform apply command will execute the actions proposed in the plan. So the Terraform apply will execute. Terraform apply will execute the actions proposed in the Terraform plan. So when you run the Terraform apply without plan also, when you run the Terraform apply without plan also, Terraform again will automatically create an execution plan. Even though you run Terraform apply directly without a Terraform planning also, the Terraform apply also will create an internally execution plan. Then it will prompt you, it will ask you to approve that plan, to take the action. Even though without running Terraform plan also, if you execute Terraform apply also, again this will also will try to compare the current configurations with the state file, and it will show you the what actions to be taken, but it will ask you a confirmation whether you want to proceed, yes or no options, like that it will ask. If you say yes, then only the Terraform apply will perform those actions on the resources. If you say no, it will not perform those actions. So the Terraform apply command, the Terraform apply command is going to execute, the Terraform apply command is going to execute the actions proposed in a Terraform plan. When you run the Terraform apply without planning also, the Terraform will automatically create an execution plan. As you had run the Terraform plan, like that only it will create an execution plan. And again it is going to prompt you. Prompt you means whoever is running that configurations, it will prompt you to approve that plan. Once you approve that, it will take the indicated actions that can be creating, updating, deleting, it will do. So this is where the actions will be performed by Terraform. That action can be creating a resource. It will create a resource if the resource exists in the configuration, but if it is not there in the state file, it will create a resource. And again, this Terraform apply can update also. This Terraform can apply can update also the resource. When it will update the resource exists in the configuration, that is Terraform code, and that resource also exists in the state, the current state. But if there is a differences in the current state and desired state, in that case, this Terraform will update that resource. It can create a resource, it can update the resource, or it can destroy the resource also. Terraform apply can create a resource, update the resource, or destroy the resource. So when resource will be created, suppose in the Terraform code, in the Terraform configuration, there is a resource exist, resource details exist, but in the state file, there is no entry for that resource. In that case, it will consider this is the new resource has to be created like that. So that time it will create. If you are running a Terraform apply, it can do the updates also. When it is going to update the resources, so there is a resource in the state file and there is a resource in the configuration file, that is desired state and current state, both resources are there. But in the current state, the values is different. In the desired state, the values is different. In that case, it will say I have to update and I will update that resource like that. This Terraform apply can destroy the resource also, delete. When it is going to delete, suppose you have a resource, in the state file, but in the code, suppose you already created this server via Terraform, the resource is there in the state file, but here let's say you have commented this code, let's say you have commented this code, and if you apply, then what it will consider? Suppose in you already created a resource via Terraform that is already there in the Terraform state, current state it is there, but in the code you have commented this block, or in the code you have deleted and again applied. That time it will say, it will try to destroy that resource, because the resource exists in the current state, but the same resource doesn't exist in the desired state. Desired state is your code, you have commented or you have deleted. That time it will think, okay, this resource has to be destroyed like that. So the Terraform apply can do the creation, the Terraform apply can do the update, the Terraform apply can do the destroy also. But which resources will be created, which resources will be updated, which resources will be destroyed, this is how it works. Suppose in the Terraform code, there is a resource. In the Terraform code, there is a resource. This resource exists in the code, but there is no resource already created and mapped that resource in the state file. In the desired state, there is a resource. In the current state, in the state file, there is no resource exist. In that case, Terraform apply will do the creation. In the desired state also it is there, in the current state also it is there, but if there is a differences, between the desired state and current state, then it will try to update that resource. But if in the current state also there is a resource, in the current state also there is a resource, in the desired state also there is a resource, but there is no differences, in that time what it will say, no changes required, no change, because both are matching. In the current state there is a resource, in the state file there is a resource, but in the desired state that resource is removed. In your code you have commented or removed and again you are running, again you are applying. That time what it will do, the resource exists in the state file but not in the desired, so that time it will destroy. So understand what this Terraform apply will actually do. It is going to perform those actions according to the desired state and current state of your resources. Clear? Sometimes in the interviews they may ask in a this much depth also. So how Terraform apply knows which resource to be created, which resources to be updated, which resource to be destroyed, because Terraform compares the current state with the desired state. In the current state is your state file, the state file which is already created and maintaining the resources, and the desired state is your code. It will compare these two and identify what resources to be created, what resources to be updated, what resources to be destroyed like that. But after applying only that it is going to perform those creation or updation or deletion like that. Clear what this Terraform apply will do in the workflow? Understand what this Terraform apply will do? It can create, it can update, or it can delete the resources comparing the state, current state and desired state. And there is something called a Terraform destroy. Terraform destroy, the name itself it is saying what this Terraform destroy will do. It is going to delete whatever resources it is created. But in real time, are you going to sequentially run like this? Whether you are manually running or via pipelines running, are you going to say Terraform init, Terraform apply, and again Terraform destroy like that? If you execute Terraform destroy, what it is going to do? It is going to completely remove the resources created by the Terraform module. But in real time, are you going to destroy after immediately apply? After apply, are you going to immediately destroy? No, right? So if you don't want that resources in the anymore, suppose you don't want whatever resources has been created for anymore, suppose that application is sunset, they are sunsetting that application, whatever application they are using this infrastructure, there is no customers for that application, or they don't want that application to be running. So that application, there is no customers, there is no users, they are sunsetting that application. That time, can you completely destroy whatever resources has been created for that application team by running the Terraform destroy? Yes. So that is how you can do this. So is everyone clear? What is this Terraform workflow? The most important stage is a scope only. You have to identify the scope. And again, maybe initially you have a requirement. Initially you have a requirement to create a two servers. You have created infrastructure you are managing, but later the requirements are getting changed. Maybe for the same application team, you may need to create a one more server or maybe load balancer like that. Can we update these configurations? Can we keep on update this code the way you are introducing new features in the application? Can we create a new resources also by writing the code and running this code again and again like that? Based on the changes, you can modify this code, you can add additional resources. If required, you can remove the additional resources, you can modify the existing resources, you can keep on enhance this code, keep on modify this code based on the requirement, and you can run this code up, plan apply like that. But if you don't want that resources anymore, you can run the finally you can run the destroy, so that the destroy will try to destroy the resources created via that Terraform. So you identify the scope of the resources, then you write the code, then you initialize the code. This initialization will initialize, it is going to perform the initialization task for the Terraform. Like it is going to download that providers or a plugins. Via that plugins only, the Terraform will create a resources and manage the resources. It will download the plugins, it will do the backend initialization, it will download if any modules used in the Terraform code. Then you can validate the configurations for syntactical checks. But this validate is not mandatory. Even though without validating also, if you run apply or a plan or destroy, if there are any syntactical issues, it will throw error. But if required, you can validate. But this Terraform init is the first command. The Terraform init is the first command you have to execute before, if you created a new configurations or if you have cloned existing one from the version control system. And again, even though you have already executed, but if you have done some changes to the Terraform block, in the Terraform block you have done some changes, maybe you added one more provider. Currently you have only AWS provider, maybe you added one more provider in the Terraform block, or you modified your backend. That time, do we need to again execute this Terraform init? Yes. So again, we need to run the Terraform init to do the initialization. And it is safe. It is safe to run the Terraform init 100 times also. But you are only doing the Terraform initialization. That time, is it going to create or update or destroy the resources defined in the Terraform configurations? No, it is not going to do anything. Then you can plan. Plan is like a preview. Plan is like a preview. It is going to do the preview, like a trailer what a Terraform can do, like in the movie, right? There will be a trailers, right? What hero will do throughout the movie. So this preview like that only. So what resources it will create, what resources it will modify, what resources it will destroy, it will preview the changes. But the how it will show that, how it will identify this plan, how it will identify, it is going to compare the desired state with current state. The desired state is your Terraform code, Terraform script configurations. The current state is the state file that itself also created and managed by Terraform only. Whatever resources it is going to be created, that will be created and maintained in the state file also. So it will compare those two and it will show the preview. If you want to proceed, you can apply. Apply will take the actions proposed by that plan. If you don't want that resources anymore, you can destroy. But don't run step 1 Balajis are set the Terraform apply, step 2 Balajis are executed Terraform destroy. So don't run that way. And don't tell in my name also. In the company, suppose you destroyed some infrastructure, why you have destroyed? So don't tell sir Balaji told to destroy. I destroyed. Okay, it is destroying means you are destroying your servers, so your applications will stop working. And don't blame my name. Okay, I hope you are getting what is this Terraform workflow. So with this background, we will try to start writing the code. With this background, we will try to write the code. Using HCL, we will write the code. Using Terraform core, we will run the commands. So we will understand slowly, step by step. These are very, very important. Without learning all these things, if you directly jump into the Terraform, creating a code, executing a code, you don't know how Terraform is doing all these things. You may think Terraform is like a magic. So state lock means what we will discuss. State lock means what we will discuss at a time. Suppose as a team, you are working with Terraform. I am also running the Terraform configurations at a time, and you are also running the Terraform configurations at a time. In that case, is there a chance for a race condition? Race condition means I am also running the Terraform apply, you are also running the Terraform apply, both are using the same code and both are pointing to the same state file in the remote backend. That time, there is a race condition. Who will win the race? Whether I will get the state file first or you will get the state file. Otherwise, at a time, two Terraform process modifying the state file, there is a chance for state file corruption. The state file get corrupted. So that is where there is a state locking. This we will discuss in the remote backend. So when we go and discuss about remote backend, why we need to lock the state file. So if at a time if two Terraform process is trying to make the changes, the state file has to be locked for one Terraform process. Once one Terraform process completes its execution, completes the state file update, then the lock will be released. So other guy can acquire the lock and run the scripts like that. Otherwise, there is a chance for a race condition and the state file corruption that we will discuss in the advanced classes. So what is that Terraform state locking? So we will try to understand all these things in the future sessions. And what are the various commands? We have so many other commands like Terraform plan, Terraform apply, Terraform destroy. Similarly, Terraform refresh is there. Terraform refresh is there. Terraform state file related commands also there. So Ramesh is asking what is the Terraform show command. This Terraform show command is to show the resources which is already there in the state file. Suppose you want to know in a human readable output, you want to see the state file. So you can execute the Terraform show command. Terraform show command will show the state of the current resources in a human readable format. So this all these commands we will discuss. Terraform show is just to show the output from the state file in a human readable format, which means what resources is already there in the state file. If you have to see, you can use Terraform show command. All these commands we'll discuss later. Don't worry. So first understand what is Terraform, what Terraform does, how Terraform works, what is what here. So from here, I'll continue tomorrow. In tomorrow session, what we will do, we'll try to install Terraform. Did I install Terraform in any system? That can be my local laptop or a desktop which I am using? No. So far, I have not installed Terraform core. So tomorrow session we will install Terraform, and we will see how Terraform can be installed in Windows, how Terraform can be installed in Mac, how Terraform can be installed in Linux or also if required. And we will try to download and install Terraform. We'll try to download and install Visual Studio Code, because we are going to write the code using Visual Studio Code editor. So we will see how to install Visual Studio Code. And there is a Terraform plugins, Terraform extensions to the Visual Studio Code, how we can use that. And also we'll see how to set up AWS CLI if required in the future, if you have to work with AWS. So that will continue tomorrow. So from here, we'll continue tomorrow, guys. Yes, tomorrow we'll take class, because only 3 days, 4 days a class a week won't speed up the batch. So tomorrow we'll take maybe 1 hour maximum. We'll just do the installation, nothing else. We'll do the Terraform installation, and we will install Terraform software, and we will install Visual Studio Code locally in the laptops or desktops, and we'll see the installation part only. But after that, maybe in the next week, that is Monday onwards, we'll start writing the code. We will start with very simple things first. We'll try to start with very simple things. Slowly we'll go on advanced concepts, all functions, loops, variables, meta arguments, all these things we'll get into. Then slowly we will jump into all the advanced concepts from the next week onwards.
Hi sir, this is Soumya here. I have
Yes.
a doubt.
Mm,
Sir, in the provider block, we'll mention, for example, AWS, and then we'll mention the region equal to, say, for
mm,
example, AP South 1 in the
mm,
provider.
mm,
So the resources will get created in that particular region. Say, for
mm.
example, for a particular resource, I wanted to create in a different region. So in
Mm.
that time, there will be a conflict, right, sir? So how can we
What
do that?
conflict? What
Uh,
conflict?
for, for example, AP South 1 is where the resources will get created. So
Mhm.
particularly, I want a EC2 instance to be created in, say, North Virginia region. So in
So
that time,
you update this region. So what it does, it will destroy whatever resources which is already created in a Mumbai region. Then it will try to create a resources in a North Virginia region, because in the state file, the resources are created in a region like Mumbai. Also, it will maintain the region availability zones. In that case, the region itself, if you update in this provider block, the existing servers, whatever you have created in a Mumbai region, that will be terminated. Then the new servers will be created in the new region, whatever you have mentioned.
oh, okay, okay. So the entire thing will be getting deleted, whatever is already existing, and then
Yes, that is
new
what you
resource
are
will.
also, yes, you are also expected to do this, right? Because same module, same resources, same configurations. But if you want to leave this as is, you want to create differently, maybe you can go and do via different module. I hope you are getting what do you mean by different module. So you create a different Terraform project. In the Terraform project, you define the resources and you run there. So that will have their own state file. So everything is mapping
Okay.
with state. So the current state file is used with this current configuration. Suppose if you are maintaining other configuration, that configuration will have its own state file.
Hmm. Okay.
So, sir, I have a
Okay, sir.
question also, Rajiv here.
Yes.
So that means one project will be able to create the infrastructure only in one particular region. If I want to create in multiple regions,
You can do that.
same EC2 instance. Yeah.
Guys, don't be urgent. We will cover. Okay. I don't know, but still you guys are very fast. Okay. Here I
No,
can
no. I
have a
mean,
two.
I don't know whether my question is a future question for this course or not. But since the same type of question was asked, it came in my mind that what if I want to create in
Yes,
multiple regions?
I will show that. But since you are asking, let me
Okay.
tell right away whether you understand
I
or
mean, you
don't
can just
understand.
give overview, high level also. That's fine for me. I mean, it's not need to
Okay.
be much
Here you
detail.
can have a one more provider block. Same provider block for AWS. One more provider block. You can have maybe AP Southeast one. AP Southeast 1, like that. This is Singapore.
So your
Here,
screen is not able to see what you are writing. It's
so
what
let me
document
show
which
you.
is.
Okay. So here you can have a one more provider block. The way you have a one provider block, you can have a one more provider block. In this provider block, you can mention region as a AP Southeast 1, North Virginia, whatever it could be. So here by default, this resource will be created using this default provider section. Otherwise, suppose one instance in Mumbai region, another instance in another region, there is something called a life cycle block. I will come to that. That's what you don't
No, no, no,
understand
that's
what is
fine.
this life cycle.
That's fine. Just give a high level, I mean, so that you know.
So life cycle block you can use. In this life cycle block, you can give provider alias. There is something called a provider alias. So suppose here, if you say this provider alias, this you can give, you have given the name for this, maybe one more provider block you have given. Suppose here you have mentioned AWS Singapore, like that. This is like a provider alias. So this resource will be created using this provider settings. This provider settings, in this provider settings you have told region is Singapore. So this instance will be created in a Singapore region. This instance will be created in a Mumbai region, because here I have not mentioned the provider alias. Since I have not mentioned the provider alias, so it is going to use this default provider settings. This is considered as a default provider settings. This
Oh,
is
okay,
your
okay.
other provider settings. So if you mention this lifecycle block and a provider alias, so this resource will be created using this provider settings. That can be Singapore or Hong Kong, whatever it is.
Yeah, yeah, that's great. Understood. Thank you.
Uh, Sir, here I have one question, sir. For example, if we create a variable like a region, sir,
Hmm.
at the time of running, we can pass it to different region. It will create it, right? Through
But
variables also.
yes, but what about suppose you can parameterize, but in the state file, when you initially run, you have passed Mumbai region. In the state file, server will be created in a Mumbai region, but in the same state file, again you are using but a different region. As I already said previously, what happens? The existing server which is created in the other region will be terminated, and new server will be created in the new region. Parameterization is different, state file is different. I hope you are getting parameters. You can pass the input to the Terraform configurations using parameters. Using that values, the resources will be created. That resource details will be maintained in the state file. Same state file again you are using, but you are passing different values. In that case, existing infrastructure gets destroyed and new infrastructure gets created. Let me tell you, are you going to create infrastructure for all applications, all projects in all the regions using same module? Let me get more clarity on this point. Using same code, same script only, you are going to create an infrastructure for all the teams, all the projects in your company? No, right? As I already said. So you have a separate Terraform code base, separate Terraform code base for each team, each requirement. So each Terraform code, each Terraform module will have its own state file. So you are going to use those Terraform code to create a resources for different teams, different applications, like that. I hope you are getting that point. Clear or still confusion? If you are writing everything in a same, it is like a monolithic, difficult to maintain the code. I hope if you are from a development background, this Terraform is also development only, infrastructure development as a code. It is like monolithic. You will mess up everything in a same code base. You lost the control to the code. There is no maintenance, right? The way the applications are being developed in a microservice architecture, here your Terraform code also separate repositories or separate code base for each requirement. But again, you can create a reusable code using modules, using variables, like that. You have to follow. I will show this all these things how to do. Same code how I can use for creating an infrastructure for dev, how I can create an infrastructure for production. Same code base, but I can maintain the different state files also. If I am using a remote backend, local backend not possible. If I am using a remote backend, same code, same backend, but different state file for dev, different state file for production, different state file for staging I can maintain. I can execute Terraform init with the dev state file, dev variables, production state file, production variables, like that we can do. So we will see all these things in the future classes. So thank you. That's it for today. From here, I'll continue tomorrow, guys. See you tomorrow. Tomorrow we'll just set up the Terraform installation. Actual writing of the Terraform configurations we'll do from Monday. See you tomorrow, guys.